Hare Krishna to everyone. So we'll write our first GPIO register definition structure. So open the reference manual. In the reference manual, go to the GPIO register. So this is our GPIO registers. First is GPIO model register, and second is our speed register, output speed register, and third is our input data register. Third is our pull up and pull down register. Sorry, pull up and pull down register. Fourth is our input data register, and fifth is our bit set reset register. Likewise, we have the registers, so we need to declare the register addresses. So here you can see these are having some offsets, like if you go with the first register, model register, that is having offset of 0 cross 0 0. So, and if you open our .h file in that one, so this is our GPIO A port with the address of 0 cross 4002000. So plus with that offset, okay, so it is 00 means that same address will come, and if that plus 0 cross 04 means it will add 0 cross 04 in that with respect to GPIO. So likewise, we need to map all the GPIO registers with respect to the GPIO ports. So so what we'll do, we'll not declare likewise, so we'll make as a structure, so it is easy to write also and it is to understand also. Okay, so first we'll write our brief GPIO register. Okay, in that one we'll make as GPIO register definition structure. These are our register definition structure. So first register is our model register. Okay, and so we'll give the small description of that model register here. This is our GPIO port register with the offset 0 cross 0 0. So here if you open, it is having offset of 0 cross 0 0. Okay, so our, if you point this register with the GPIO A, means GPIO A, if you point with the register definition structure, so and if you point with the model register, so it will give the register as our HP means this GPIO A plus this offset, so it will point to the model register. Likewise, uh, this is second register is our output type speed register. Output type, okay, output type register, speed register. Okay, so this is our GPIO port output type register. The offset of 0 cross 04. Okay, so after that we have output speed register. This is our output speed register. With offset of 0 cross 08. And our third register is then pull up and pull down register. Pull up and pull down register. Okay. Just write with the offset of 0 cross 0 C. Then we have input data register. After that, likewise you need to create, so I'll make as one copy for each. So this is our input data register. Can give, this is our input data register. Sorry, this is our input data register with the offset of 0 cross 10. Then we have offset of 14, 0 cross 14. Here you can go and just search output data register. So offset is 0 cross 14. Okay. Then after output data register we have bit set reset register. With the offset of, just open the reference manual and go to the bit set or reset register. We have the offset of 0 cross 18. Likewise after that we have lock register. This is our GPIO configuration lock register. Right here, port. This is our GPIO port configuration lock register with the address of, just open the lock register and 0 cross 1C. This is our GPIO lock register address. And then we have alternative function register. If our this is our GPIO port, alternate function, remote register, keep on only. So in the alternative function register you can see we have, first is our low register and second is our high register. So if you make as high and low, that is also fine. Like if you GPIO alternative function register low and AFR high, you can make and you can give that addresses, that is also fine. But instead of that, you can create one array of size 2, and if you mentioned 0 and 1, so it will point with respect to high and low. Okay, so and this will give as offset this first is our offset, low register having offset 0 cross 20 and high register having offset 0 cross 24. So it will give the offset first is 0 cross 20 and then 0 cross 24 for register 1. Okay. So this we have, this is our GPIO structure, and the GPIO structure, just open our reference manual. In the reference manual, just open the basic structure. So this is our input output pin. From here it will sense our input if any data is logging through this input pin. So it will go from this, this is input, our input engine. It will go from semi trigger to semi trigger, it will go to our input engine. So this data sampling rate of our input engine is every AHB clock cycle, and that our AHB clock cycle is too much high frequency, up to 180 megahertz. So that up to that 180 megahertz rate, our data is changing. So capturing the data with this structure, it's not sufficient. So we need to make that that register as a volatile. So just define the structure volatile VO, just make as a volatile, so it can capture the data every HP clock cycle. Okay.